Okay. So this is just an elaboration of PV equal to nRT. This is an example. If you're given a mass of a gas, this is a conversion of how to find the N, the molar of gas, right? So you're given a certain gram of the gas, given the volume in liter, temperature in Kelvin, pressure in kilopascal, find the molar of mass. So you use PV equal to nRT. R is 8 point something as a standard, all right? So just need to add in one more definition, which is molar gas, mole equal to mass divided by molar gas. You rearrange, right? You take the mass divided by mole, right? So PV equal to nRT. It asks you to find molar gas. So how you find molar gas is you from the mole. So PV equal to nRT, you have mole. Put in the value of P, V, and R and T. So in this case, we use R as a standard, 8.314 liter kilopascal divided by mole Kelvin. Press your calculator, you get certain mole, and this answer you can see is 10 power negative 3, and I give a minimum of 4 decimal place. In your exam, give at least 3 decimal place. In exam, give at least 3 decimal place. So from mole, you can find the molar gas, you are given the mass. So this question will ask you to guess what, if you come to final exam or test, it asks you to guess what is that gas from periodic table. So this is how the test, the difference between tutorial question, test and final exam. So once you have the N, you have the mass, you take the mass divided by the mole, you get molar mass, which is gram over mole. Find the element in periodic table, all right? So you get 28.1 gram per mole. So if in the periodic table, not periodic table, but it can be a combination of gas, right? Gas can be H2O, it can be different kind of mass. If we tell you that it is a pure mass, pure gas means it's a CO2 or nitrogen, oxygen, helium, so on. So 28.1 gram, if you refer to periodic table, so it can be a lot of combination. It can be CO2, CO, and so on. Okay. So at this stage, we stop at how many gram per mole? In later chapter, when we look into the reaction and so on, we'll use this information to further calculate for individual element of the molecule. Right? Okay, so another similar question, also same. So you're given the mass, you're given the volume, you're given the temperature, you're given the pressure, and the unit is given. So it asks you to find molar gas. Molar gas means you need to use the conversion. Mole equal to amount of gas, N equal to small m divided by capital M. So this one you can do in your tutorial question, in your revision. I give you the answer. Same procedure, same procedure. Any question so far? Can So these are the two. Okay. Now we need to answer ideal gas and non-ideal gas. How to differentiate between ideal and non-ideal. So ideal gas, we have this give you the answer. Ideal gas confusion at high temperature and low pressure, we use the kinetic molecule theory in ideal gas. Ideal gas condition, we use high temperature, low pressure. Use high temperature, low pressure. We assume kinetic molecule theory applied. There are 4 assumptions just now. It's early when we start the chapter 2. We mentioned 4 assumptions for the kinetic theory, a molecular theory. So we apply for ideal gas. In ideal gas, particle size is small compared to the space, and this one is the assumption in the kinetic molecule theory. That one. Interaction between particles is insignificant. This one is in the assumption number 3 or number 2. They do not interact. They do not react to each other. Non-ideal gas means you will see low temperature, high pressure. If we have low temperature and high pressure, kinetic molecule theory do not apply. Means in non-ideal, kinetic molecule theory do not apply. Or in other case, reaction happen. Something changes the molecule or gas. Okay. Okay, so I just put a highlight. You may assume in this module, you will have ideal gas behavior unless the question state otherwise. Okay. The last part of the chapter 2, we need to find mixture of gases. We introduce you another law called Dalton law. Dalton law. This one, before I forget, is important for your final exam. Final or test one, I forgot already. This one is important. There's one question in this section. Okay. So according to the kinetic molecular theory, each component of gas act independently. Example, nitrogen, you have 78% of total pressure of the atmospheric pressure, right? So this is the composition of Earth, gas in the Earth. There. Or sometimes I print the wrong there. Okay. So nitrogen, you have 78%, oxygen 21%, and so on. Of course, I won't ask you this one. Important is this equation. Partial pressure equal to fraction multiply spelling error is component COMPONENT. Small error there. Multiply by total pressure. Okay, partial pressure component equal to fraction composition. Fraction means 1 divided by something or 0 point something, right? Of total pressure. So how to use this one? So if the question asks you to use Dalton law, you need to write this one. Partial pressure component equal fraction composition multiply pressure total pressure. For example, in this container, you have helium and Ne. So let's say you have 80% HE and 20% NE. So P total in this container is 100 kilopascal. To find the partial pressure component, partial pressure of HE equal 0.8. 80% is 0.8. Right? Fractional is you convert percentage into fraction. Right? 80% is 0.8, or 80 divided by 100 is a fraction. Right? Multiply by total pressure, which is 100 kilopascal, you get 80 kilopascal. This is how you apply the equation, right? Okay. Yeah? Any question? No, huh? So if we take Earth, if we take Earth, total pressure is 100 kilopascal. We change 100 kilopascal into 1 multiplied 10 2 power 2. So if you use this equation, partial pressure of nitrogen equal to 0.78 multiplied by total pressure, you will get 78 kilopascal. This is to find the partial pressure of gases. This is just example. Example. The rest is just illustration. This equation is important. What actually is Dalton law say? Dalton law say total pressure equal to partial pressure of component A plus partial pressure of component B plus partial pressure of component C, and so on. This is important. Partial law, Dalton law of partial pressure is important for your test. For info, this one is important for your test and final exam. Important, huh? Okay. Okay, so for, let's say we take atmospheric pressure as example. If your total pressure is 100 kilopascal, so how do you apply Dalton law? Dalton law equal P total, PTOT, or you can write the full PTOTAL total equal to PN2 plus PNO2 plus P argon. Okay, so you get 100 lah. So this is the last step of the equation, the exercise later. The last step. Okay. It's just an illustration. Important is Dalton law general equation. Dalton law of partial pressure equation. Okay. So let's say the question gives you something like this. A gas mixture contains equal number of moles of HE and NE. The total pressure mixture is 3.04 10 power 5 Pascal. What is the partial pressure of HE and NE if you use the Dalton partial pressure equation? This is very direct. So what is the answer? A, B, or C? What is Dalton law partial pressure give you? P total equal to P1 plus P2 plus P3 and so on, or PA, PB, PC. Here you only have 2. P total equal PHE plus PNE. Then it tells you equal number of mole. Total pressure mixture is that. So you need to find lah. If the N is equal, then it should be half lah. Okay, mixture, another question. Mixture of helium, neon, argon, total pressure given. Partial pressure, helium given, neon is given, one missing is argon. So basically, just fill in the blanks. Call out Dalton law or partial pressure equal to P1 plus P2 plus P3 or PA plus PB plus PC. Substitute. You need in the test, you need to give me the what general equation. You need to modify the equation from Dalton general to the scenario. For example, P thought equal to PA, PB, PC equal to P thought equal to, in this case, you need to write P helium plus P neon plus P argon. Then you substitute the value. Okay, they ask you to find argon, simple calculation, you get 14 kilopascal for argon by using Dalton rules. Okay. So quite standard. Try to observe the way we expect in your answer. You write the general equation. What is that? Modify the general equation. Then rearrange the equation. Substitution. Then find the answer. This is the structure that we expect in your test or final exam. Okay. Okay, this is just an application what actually happened to when you climb high mountain and so on. So if you lack of oxygen, your body will have a scenario called hypoxia, which is you are low oxygen, right? Low oxygen, you have one condition called hypoxia. This one you read lah. So human lung, we able to take in 21 kilopascal at sea level. If the total pressure decrease, the partial pressure also decrease. Because Dalton law tells us P total, if the P total increase, the partial pressure of individual gases also decrease. So if you climb higher and higher, the amount of oxygen also decrease. Okay. So at the top of the Everest, the total pressure changed from 101 kilopascal to 31.5 kilopascal. So the oxygen become, you take the calculation to calculate the partial pressure, PO2 equal to 21%, the fraction, multiply by total pressure, you'll get 6.615 kilopascal. Your lung need 21 kilopascal, but in Everest, you only have 6.6 kilopascal. That's why it's very sophisticated. You need to take in a lot of oxygen in Everest. Okay. Okay. So low oxygen level in your bodies will cause a psychological effect called hypoxia or oxygen starvation. You will hunger for oxygen. Hypoxia. Okay. So if you take an aircraft and the aircraft have pressurized problems, means the mechanism in the cabin suddenly lose altitudes, the aircraft lose altitudes and the mechanism, let's say you fly at a high level, 30,000 feet, and suddenly the cabin pressure mechanism broken. You will have hypoxia. You experience hypoxia, right? Because the environment total pressure change equal to the environment already, not as in the cabin pressure. Okay. So same. This is me in the underwater. So same. So if at 30 meter, this is about 20 meter. This picture is me at 20 meter. So at 30 meter, breathe, total pressure is 410 kilopascal. It make the oxygen fraction always same, because in the oxygen tank, we do compress the air. Compressed air, the percentage, we take air from atmosphere, so the fraction always same, 21% multiplied by 410. You will get 68.1 kilopascal. So actually in the lung of the diver at 30 meter, you actually take in 81.1 kilopascal. Okay. So you have higher content, oxygen content in the lung. So you have too less oxygen also not good. Too many oxygen also not good. Right? So this is just some physiology, what happened to the bodies, right? So in the surface, P total is 101 kilopascal or 100. So at the surface, the lung, partial nitrogen and oxygen is 79 and 21. But below water, total pressure increased from 100 to 400. Oxygen increase, nitrogen increase. The amount of oxygen is increased. You will have oxygen toxicity if not careful. Okay. Another equation. Um, um, how to read this this chart is based on the percentage of your oxygen, right? So if your it depends on the pressure. So if your pressure is 1 atm, your 100% oxygen at the surface means the value is 1. If you go deeper underwater, atmospheric pressure will increase. So the oxygen content, if it's more than half, you need to rest already. Means you'll go into toxicity, oxygen toxicity. If you go to high level mountain, your oxygen will become less and less. Less than 0.1, you are having hypoxia. This is just application. Application. This one you read. So in scuba diver, that's why we do not come out very fast, or we do not come down too fast, come up too fast. There's a sickness symptom called the band. The nitrogen in the blood will come up very fast. It will make damage to your lung. Okay. Okay. So this is just an exercise. Calculate the pressure, partial pressure. Partial pressure. You see, partial pressure already means you need to use the Dalton law. This only this chapter that use partial pressure. You see partial pressure, you need to write Dalton law already. Dalton law, then P total equal to PA plus PB plus PC. You get 1 mark if you write that. Mixture contain 2% hydrogen, depth of 90 meter, where total pressure is 1010 kilopascal. It asks you to find oxygen. So partial pressure of oxygen equal to fraction multiplied by total pressure. So remember to change percentage into fraction. And this is just a reminder, right? Don't straight away use percent. You need to write in fraction form. Then you will get partial pressure in kilopascal. Okay, you don't need to write in 10 power something if it's too low, the number. You can straight away write 200 kilopascal, also correct. Right? So this one asks you to find the total pressure, reverse the calculation. It gives you fraction, 5%. Want to adjust the total pressure so that P2 is 21 kilopascal. It gives you the percentage fraction. It's breathing in 5% of oxygen. He want to adjust the total pressure so that P2 is 21 kilopascal. So you write the partial pressure equation. Partial pressure equal to fraction multiplied by total pressure. The first equation that you see. Put in the fraction. This one become 5 divided by 100. This one is on the left, right? So this one, partial pressure equal fraction multiply P total. So in this case, we are given 5%, 21 kilopascal. So here, we move to here. Then you get something like. Okay. Now this one is more on the chemical process. Okay. You should be familiar with this. Let's say we have a reaction. This one will be in your chapter 3 onwards. Let's say you have a mixture of zinc plus HCl is an acid. Zinc plus acid, you generate a product, ZnCl plus hydrogen. So how you collect in experiment? You put in zinc and HCl, you channel the tube into a container. So this one is your water. You put your tube, go inside. This one you collect hydrogen. One you read, read. So partial pressure. Just now we studied partial pressure. I just want you to show the one word called vapor pressure. Vapor pressure, vapor is referring to water molecule. Partial pressure of water in the process is called vapor pressure. Okay. So vapor pressure of water, you have a standard chart that I give you in the tutorial question. Different temperature give you different pressure. So here, this is an exponential chart, right? Pressure versus temperature. Okay, so back to here. If you want to collect hydrogen gas over the water at total pressure, so and so, temperature given, what is the partial pressure of hydrogen gas? You need to look at the equation, the chemical equation. How many mole hydrogen was generated in this equation? How many mole? 1, 2, 3. How many mole? Hydrogen? 1. If you don't see anything, it's 1. So P total equal to water plus hydrogen. At this moment, you just accept water is there. Later, we'll prove water is there in chapter 3 and onwards. At this moment, you just accept water is there. Okay, you put in the value. Total pressure is 101 kilopascal. Hydrogen pressure is missing. Water, you need to refer to table 317. Why 317? Because the temperature is 298 Kelvin is given in the question. Need to refer to table. If the question required you to find vapor pressure of water, you need to refer to this table. Different temperature give you different pressure. Okay. So this will be some of the mistakes. If you don't refer to this table, you get wrong answer. Okay, at the end, 98. Okay, rearrange the equation. Partial pressure for hydrogen in this case is 98 kilopascal. Okay, so this one is nothing complex. Again, how I give you marks in test, general equation, working, and final solution, final answer with the unit. So here, you will get 3 marks here. General equation, 1 mark, working 1 mark, final answer 1 mark, 3 marks. Okay. So here in chemistry 1, you already know how to find coefficient in the what I call stoichiometric equation. Okay. So now what we want to do is we use the principle of stoichiometric to find the number of mole. Okay. So this reaction involves gas. We are now at gas. We focus on gas or products. Amount of gas is specific in volume at a given temperature or pressure. So if we involve with volume temperature, we need to recall back the ideal gas law. Okay. This case, PV equal to nRT, rearrange PV equal to nRT, put your N on the left-hand side, then you will find the N. Okay. How do we apply for chemical reaction? Just now, before 2.10 is all without chemical reaction. If you see question with this equation, on the left-hand side, A plus B equal to C plus D, this kind of equation, you need to start to look at step in 2.10 and onwards. For example, consider a reaction. You see reaction already, you need to use the steps. So here, you are synthesis of ammonia, A plus B equal to C plus D. Here only have C, right? So how many mole of hydrogen? 3 mole. 1 mole, 3 mole of hydrogen plus 1 mole of nitrogen, you'll get 2 mole of ammonia. Okay. He asks you how many moles ammonia are formed by complete reaction when you use 2.5 liter of hydrogen at this temperature, this pressure. So you have temperature, you have pressure, you have volume. Straight away call out PV equal to nRT. You need to use ideal gas equation already. Assume there is enough N2. So how do we determine the moles? You need to find, use the PV equal to nRT, find how many moles of H2. Why H2? Because it gives you hydrogen. It gives you left hand side. He asks you right hand side, how many is formed? In this case, nitrogen is nothing, not your concern. It asks you, you input this one, how many come out from your experiment? So you convert mole, PV equal to nRT, then you convert mole into ammonia. How many mole hydrogen you get to get 2? You need 3 mole hydrogen to get 2 mole ammonia. Understand? Indeed, this is a complete state, a balanced equation. You need to put in 3 mole hydrogen to get 2 mole ammonia. Ratio 3 to 2. Always, you get 3, you put in 3, you get 2. You understand? Huh? So this actually, you need to write the equation 2 mole NH3 double dot 3 mole H2 or something like that. Okay? Okay. Start to give you the steps. So this is what actually we expect lah. You need to write the ratio by looking at the stoichiometric equation. You need to write how many mole generate how many mole. This question asks you hydrogen. So you look at hydrogen. It asks you ammonia. So you write how many mole equal how many mole product. Then you do conversion. The rest is just conversion. Okay? He asks you how many moles. So you need to put in this one. You need to convert this information. 2.5 liter of hydrogen. Convert this information into moles. Get the mole first. Convert this one. Every time you see stoichiometric question, first step in your mind is, I need to find the mole. I need to convert everything I see in a question as a mole. Yeah? Okay. So this will be the last slide lah. So you see how I convert. I find the N, PV equal NRT. I rewrite N equal to PVRT. P you have, V you have, R 8.13 something. T you have, you press calculator. Again, I skip all the substitution already. You get N equal to 0.150 mole. You get this answer. Take this N, plug into ratio. If you don't know how to use this one, I write on the whiteboard here. 3 mole H2 double dot 2 mole NH3. Now you get 0.1050 H2 equal, you don't know, X. What you do? Cross. 3x equal to 2 multiply 0.1050. Rearrange. Yeah, it's just a background calculation. If you don't know lah. Okay, I substitute 0.1 multiply 2 divided by 3. I already show you on the whiteboard. Y2 above, Y3 below. At the end, the answer is 0.07 mole NH3. Of course, in test or final exam, I will ask you how many grams of ammonia will be generated. You're able to find, right? How many kilogram, how many gram, right? Mole, what is the definition of mole? Mole equal mass divided by atomic numbers lah. So you have the mole already, 0.07. Mass, okay, mass, you have mass you need to find. Ammonia equation, NH3, use periodic table. N is what? How many gram? In periodic table, N? Five. How many? N, I think it's something lah. How many? Periodic table? Periodic table? Oh, chapter 1. And nitrogen. Where? 14.007. First row, right? Okay. 14.007 gram plus 3 hydrogen is 1.00 something. Hydrogen 1.008. You use calculator? Roughly 17 lah. Roughly 17 point something lah. Okay. So here you put in 17 point something. Put to here you 17 point something multiply 0.07 more, you get the mass. Is that? Yeah. 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 Okay. This one, your homework. Go and see if you understand already. This one. Okay, I think we stop here. Okay, 2.1. Okay, we stop here.